Years ago, I got an email from my father, and it had this diagram in it. It's a map of the living room, dining room area of his house. And he and my mother, they were thinking about getting hardwood floors installed, and they wanted to get an estimate for how much it was going to cost. And the hardwood floors are sold by the square foot. So he sent me this picture, and he said, "Okay, well, figure this out for me. Tell me what the area of the floor is." Obviously, there is no geometry area formula for a very irregular shape like this. But it is still possible, sometimes, if you've got all the right pieces of information, it is still possible to find the area, even of an irregular shape like this. Now, we're not going to do this one. Doing this one requires some kind of interesting trigonometry, and we're not quite there yet. But we can take a look at shapes like this and think about how we can find the area of it. Okay, so what I'm going to do to figure this out is I'm going to use a technique that we used implicitly back when we were calculating or determining the formulas for the areas of all the shapes that we do have formulas for. When we're doing those derivations, we would take a figure and we would break it up into pieces. Say, okay, well, if I can find the area of the individual components, I can add them up and get the total area. Well, that's all I'm going to do here. I'm going to take this figure and I'm going to split it up into shapes that I do have formulas for. So I'm going to draw a line here. So that makes a rectangle out of this upper left-hand piece. And I'm going to draw another line here. That's going to make another rectangle out of the bottom piece. And I got that big rectangle in the middle. Okay, so how can I find the total area? Well, let's label these. I'm going to call this region 1. And I'm going to call this region 2. And I'm going to call this region 3. Okay, the area of region 1 is 36 times 26. The area of region, I'm going to jump around. The area, leave some space there. We'll put region 3 in the middle, region 2 in the middle. The area of region 3 is 22 times 36. And how about that big piece in the middle? Well, the big piece in the middle is a little tricky because I don't have those lengths, right? But let's see what we can do. I need this length here. Well, I know that the whole length is 120, and this piece is 22. Well, that means that this piece must be 120 minus 22, or 98. And for this whole big piece here, right, I know that this piece is 148, and this piece is 36, which means the whole thing must be 148 plus 36, which is what, 184. So that makes the area of region 2 98 times 184. Now, when I'm doing these, I like to go ahead and put the units in here. Put in that these are inches. Right? That helps to make me aware of them. Every once in a while, you'll come to a situation where you've got a mixture of units. And you have to convert them all into the same one before you start doing multiplication, addition, and whatever. Right? So by writing them in there, I find that that's just a reminder to me. And if we come across a situation where the units aren't matching up, it's a little more obvious, a little easier to see. So if you multiply these things out, we get 936 square inches. This is 18,032 square inches. And this last one, this is 792 square inches. All right, so if we add up the three components, we get a total area of 19,760 square inches. Now, the question asks for the area in square feet. Or we had a second option. We could have taken all three of those inches values and converted them to feet, right? And then done the calculations, and our answer would have just come out in square feet. Or we can just do a conversion, which we know how to do. There is 1 square foot in 144 square inches. The square inches cancel. 19,760 divided by 144 is 137.2 square feet. So I've got another example for us here, and this one, there's a little more to it. We have a contractor, he's bidding on a job to install hardwood floors in a room with this shape. So this is a little closer to the question my father was asking years ago. I know the flooring is $2.99 per square foot, and I want to know what his bid should be, just for the materials here. So to do this, I have to do the same thing. There's no formula for this for the area of this randomly shaped uh, floor. So what I'm going to do is I'm going to split it up. I'm going to draw a line here, and I'm going to draw another line here. Now, some of you may be looking at this. Well, why didn't he? There are different ways. There were different ways in the previous question that I could have split the box up, right? I'm just picking this one, and we'll see how this works out. All right, so now I need to find the areas of the individual parts. So we'll start with the easy one. This one down here, the area of section 1, that's just a rectangle. 4 times 11 is 44 square feet. Right, now this piece here, region 2, this one I'm also kind of getting for free. Nothing. It's 15 by 20. So the area of region 2 is 15 feet by 20 feet. That is 300 square feet. All right, now finally, I've got this section up on top. Now I drew this straight over, so that's going to be a right angle, which means that that shape up there is a right triangle. I know that the length of its base is 15 feet. I need to know its height. Then I can put them into the formula for the area of a triangle, and we're home free. Okay, so how can I find that? Well, it's a right triangle. Anytime I see a right triangle and I have information about the sides, and I'm being asked about the sides, first thing that comes into my head is the Pythagorean theorem. All right, the Pythagorean theorem tells me, let's not put a question mark there, let's call that x. Pythagorean theorem tells me that x squared plus 15 squared is 17 squared. All right, I can solve this. If I solve this for x, this is x squared plus 15 squared, that's 225, equals 17 squared, that's 289. Subtract 225 from both sides. X squared is 64. And if we take square root, x is the square root of 64, which is 8. And that's my missing piece. Right? So if we call this one up here area 3, the area of section 3 is 1/2 times 8 feet times 15 feet, which is 60 square feet. Add them up, and the total area is going to be 404 square feet. All right, but that's not the answer, right? Whenever you're doing these, I always tell people, when you think you're done, go back and read the question again and make sure you answer the question. The question is asking us for a cost. So my answer needs to be a dollar amount, not a square footage. So what I'm going to do is I'm going to take this 404 square feet, I'm going to multiply it by this unit cost. $2.99 per square foot. Square feet cancel. 404 times 299 is $1,207.96. The approximate cost, right? It's a good cost, a good number to put in his bid. So this brings us to the end of our conversation about area, and for the time being, to the end of our conversation about two-dimensional geometry. In the next section, we're going to add a dimension. We're going to start talking about three-dimensional or solid figures, and we'll do some similar calculations there. We'll talk about how to find its volume, and we'll also still bring area into the conversation, see how we can find the surface areas of those figures.